We have 5 times 1 equals 5 and 5 times 2 equals 10. We get 2c plus. The next term was 25. We took 5 common. 5 times 5 equals 25. We have 2c plus 5. Right? 5 times 1 equals 5. 5 times 1 equals 5. What is our answer? Our answer here is 2c plus 5. What did we do in this question? We had 10c plus 25 divided by 5. We cannot add 10c to 25 since this c is missing the variable. Alright, if it was 10c plus 25c, then we could add it together and we can get 35c. Alright, but in this situation, what is the term here? 10c plus 25. We cannot add them together since 25 does not have the variable. Since we cannot take something common, since we cannot add them together, our only option here is to take something common. What are we going to take common? We are going to take 5 common. We are left with 2c plus 5. What was in the denominator? 5. We have 5 in the numerator and 5 in the denominator, so we cancel it out. Now, can you answer this question? We have 5 here and 5 here as well. We cancelled this 5 with this 5, correct? Can't we cancel this 5 with the 5 here? We cannot cancel this 5 with this 5. Reason behind this 5 is being added to 2c. Alright, this 5 is not being multiplied or timed. This is being added to this term, that is 2c. We cannot cancel the term that is being added with another term. In other words, we cannot cancel this 5 with the 5 in the denominator. But we can cancel this 5 with this 5 here. What is the difference between the two 5s? This 5 here is being added and this 5 here is being multiplied. We cannot cancel the term that is being added, but we can cancel the term that is being multiplied. So 5 times 1 equals 5 and 5 times 1 equals 5. What are we left with? We are left with 2c plus 5. Alright, let's move on to our next question. Okay, our next question is 9x square plus 12x plus 33. This has the term x square, this has the variable x, and this has no variable. All of these terms are different. This is 9x square with the power square. This is 12x with the power 1, and this is the 33 with no power. We cannot add them together. The only option here, taking common. We cannot take the variables common since all of them are different. Or you can think, can we take x common here? So as you can see, we have 9x squared, that means 9x times x, 12x and 33. Can't we take this x common? We cannot take the x common since x is present here, but it is not present in the last term. That means we cannot take the variable common. What can we take common here? We can take the number common. 9, 12 and 33. What can we take common out of 9, 12 and 33? We can take 3 common. 3 times 3 equals 9. 3 times 4 equals 12. And 3 times 11 gives us 33. So what is the term that we are going to take common? We are going to take 3 common. We're going to write here 3 times. We had the term 9x square. We took 3 common. 3 times 1 equals 3. 3 times 3 equals 9. We are left with 3x squared. Our next term was 12x. We took 3 common. We are left with 4x. Next we have 33. What did we take common out of 33? 3. We are left with 11 divided by 6. Now Now this 3 is being timed with the whole term, that is 3x squared plus 4x plus 11 divided by 6. We can cancel this 3. 3 times 1 equals 3 and 3 times 2 equals 6. What is our answer? Our answer is 3x squared plus 4x plus 11 divided by 2. Alright. Okay. Next we have 8x plus 2 minus 4x divided by 12. We cannot add or subtract the terms, we can only take common. 8y plus 2 minus 4x. We cannot take any variable common, that is x, that is w, and there is no variable. So we cannot take w or x common. We can obviously take some number common. Here we have 8, we have 2, and we have 4. 2 times 1 equals 2, 2 times 2 equals 4, and 2 times 4 equals 8. What can we take common here? We can take 2 common. Alright, we can take 2 common out of it. We can write 2. Now what are we going to write inside the bracket? Out of 8w, we took 2 common. 2 times 1 equals 2 and 2 times 4 equals 8. 4w plus, we had 2, we took 2 common out of it. 2 times 1 equals 2. We're going to write 1. Then we had 2 common out of 4x. 2 times 2 equals 2. We are left with 2x divided by 12. This 2 is being multiplied with this whole term. Now we can cancel it out. 2 times 1 equals 2. 2 times 6 equals 12. Okay. What is in the numerator? 4w plus 1 minus 2x. What are we left with in the denominator? We are left with 6. Okay. Let's move on to the next question. We have 3x squared plus 5x divided by x. Alright. Can you add 3x squared to 5x? You cannot add 3x squared to 5x. Alright. You have the term 3x squared plus 5x. You cannot simply add them together because this is x squared and this is x. Can you take the variables common? As you can see, 3x squared means 3x times x. Alright, and then you have 5x. Yes, in this question particularly, you can take the variable common. You have x here and you have x here. Alright, so you can take x common. Can you take the other x common? No, it is only present in this one and not present in the other one. The only variable that you can take common was x. Moving on to the numbers, you have 3 and 5. Can you take anything out of 3 and 5? No, you can't. Both of these are prime numbers. So the x was our only common. Out of 3x square, you took x common. Alright. What are you left with? You are left with 3x. Out of 5x, you took x common. What are you left with? You are only left with 5. Alright. Now you have x in the denominator. This x here is being timed with this whole term. So it means you can cancel it out. You have x in the numerator as well as in the denominator. So what you have your answer, that is 3x plus 5. Alright, what was different in this question? You had 3x squared plus 5x divided by x. Alright, 3x squared means 3x times x and 5x means 5x. You can take the variable common, that is x. X is common present in this first, that is 3x squared, and x is present in the second term, that is 5x. You took x common. What are you left with? In 3x squared you are left with 3x. In 5x, after taking x common, you are only left with 5. You cancel x in the numerator with the x in the denominator, and your answer is here, that is 3x plus 5. Alright, moving on to the next question.